This video is over topic 40, numbers 23 to 25, which is some sort of mixed conversion calculations. Jump here. So starting with a man can run 6.7 miles per hour. How many meters will he cover when running for 2 minutes? So we're looking for a distance, we're given a time and a rate. So we're going to use that rate to convert from time to distance. So I'm going to start with the time, the 2 minutes. Another way to look at this is I do want to have my meters on top. That's the distance. So in my miles per hour, I do want to have the distance on top and the time on the bottom. So I could start with that. But our rate is miles per hour. We have minutes, so we need a minute to hour conversion. So 60 minutes on the bottom, 1 hour on top for that. And same thing if I start with the 6.7 miles per hour, put the 1 hour on top and the 60 minutes on the bottom to get to the 2 minutes that I have. The 2 minutes is just over 1 by itself, so it's not a conversion factor. So yeah, if I'm starting here, then once I have hours, then I can do the 6.7 miles per hour. So either way, now I would have the miles didn't cancel here, the minutes did. So the minutes cancel. So I have miles now, and I want to know how many meters. So we have 1 foot is 1 inch is 2.54 centimeters, and then 1 mile is approximately 1.61 kilometers, but those will be given to you again within the question, or you can look on the formula sheet. Sometimes it will be, especially on the rounded ones, not exactly, so it might just do 1.6 or some other variation on that. So I'm going to go from mile, I'll go ahead and go miles to kilometers here. So I put the 1 mile on the bottom and the 1.61 kilometers on top. And then I'm going to go ahead and stop there because I'll just do a metric conversion shortcut with the result. So I'm taking 2 divided by 60 times 6.7 times 1.61, or you could do 6.7 times 2 times, so these don't have to be next to each other for the miles to cancel, but times 1.61 divided by 60. So the order you do this in doesn't matter as long as the 60 is the only thing that you're dividing by. Everything else is being multiplied. And that comes out 0.3596 repeated kilometers. So there's a 5 in there, 5 and then 6. And so we want to go kilometers to meters. And if you look on the formula sheet, you have the prefixes, the kilo, then there's hecta, and there's deca, and then there's the base unit. So we're going from kilometer to meter, 1, 2, 3 to the right. I move that decimal point 1, 2, 3 places to the right. And then I'm rounding to the nearest tenth of a meter. So that's the 5 going up to a 6. So it will be 359.6 meters. Next example, a recipe calls for 500 grams of flour to make a loaf of bread. How many pounds of flour will it take to make 6 loaves? So if I start with the 500 grams, that's to make a loaf, so that's per 1 loaf. Then I can multiply that by these 6 loaves, and that's just over 1. So you might start with the 6 loaves as a starting point. And then the 500 grams to 1 loaf is a conversion from number of loaves to amount of flour. And then we want pounds rather than grams. So on the formula sheet, we have the weight conversion, or again, if it gives you in the question, use whatever it gives within the question. But the formula sheet has 1 kilogram equals 2.2 pounds, and it has 1 ounce, approximately, these are both approximate, is approximately 28 grams. So I have grams. I'll go ahead and use the 28 grams to 1 ounce, and then go from ounce to pound, so 16 ounces to 1 pound. If I do the other way, if I want to go from grams to and use the kilograms to pounds, I want to turn this grams into kilograms. So with our kilogram, kilo, hecto, deca, base unit, if I'm going from the grams, 1, 2, 3 to the left, I can move that decimal point 1, 2, 3 to the left and change that 500 grams to 0.5 kilograms. And then I can use the 1 kilogram to 2.2 pounds. So that gives me, I can take 500 times 6 divided by 28 divided by 16, or 6 times 0.5 times 2.2. The 2.2 and the 28 are rounded differently. They're both 2 digits, 2 significant digits, so they both should give about the same level of accuracy on the result. So I should expect at least the first 2 digits to match on these. So 500 times 6 divided by 28 divided by 16, or 6 times 0.5 times 2.2. We get 6.6 or 6.69. So this does actually end up, even though the first 2 digits match, if we rounded to 1 decimal place, one would round to 6.6, the other would round to 6.7. In ALEKS, of course, you'll be given specific rounding instructions. If we only need to round to the nearest pound, they would both round to 6.7, or they would both round to 7 pounds, but that would be a little probably excessive rounding. So we would probably want to the nearest tenth. Again, so you'll be told exactly which conversion factor to use. I think the 2.2 is less rounded than the 28 grams. So 1 kilogram in pounds, more precisely, it's 2.20 and other stuff. So it's not rounded very much, whereas 1 ounce in grams, it's really 28.3495. So that's rounded somewhat more. So I'm going to say this is the more accurate one and go with that 6.6. Again, you'll be given the conversion factor to use in the assignment, so you don't need to like try and figure out and make a decision of which one if there's more than one option. All right, number 25, before graduation ceremony, a faculty member walked all the way around the auditorium 7 times trying to figure out where to stand. Her fitness tracker said she had walked 3,262 yards. So how far is 1 time around the auditorium in feet? So I'm going to start with, I could start with either the 7 or the 3262, I think, because I have 7 times. That's just a base thing. And I have 3262 yards. Yeah, so this is a little trickier to use the dimensional analysis process with. We have those two pieces. What we know is that those are equal to each other, actually. So the 7 times that she walked around was equal to 3262 yards. So I'm going to start with one time around the auditorium. That's what I'm trying to find. So one time. And then I'm going to use this equation, this statement of these two being equal, to say I can put that in a conversion calculation. So 7 times on the bottom, 3262 yards on the top. Now you might just figure out, all right, if 7 times is 3262 yards, then one time is 3262 divided by 7 without using the dimensional analysis process, then that's fine. But then we do want to convert. So that would be in yards. We do want to convert that to feet. So 1 yard is 3 feet. So the 1 yard on the bottom, the 3 feet on the top. So one way or another, figuring out, just making sure, either way, making sure that the units match up as they should. Then we're getting 3262 divided by 7 times 3.